All right, let's get started. I'm really excited to be here today at Build. This is really exciting. This is my first Build. I've never been here before. Who else here has not been at Build before? Oh, quite a few people. Okay, cool. We're all enjoying this and learning about this together. Okay, so I have a challenge for you first. I want you to all take out your phones and hold them in your hands. Okay, you got them? All right, pass your phone to the person who's closest to you. And swap. You can do it. All right, you got it? Okay. I want you to look at those phones, hold them, feel them. But you almost can't do it because you're so concerned about your phone in someone else's hands. It's so uncomfortable. Why is she making us do that? Oh my God. So the reason we feel this way is because we live so much of our lives in this digital space. Those phones become an extension of ourselves. Pete Smart makes this point when he talks about designing for human-computer interaction, and he's focusing a lot on the device. And we're going to talk about this too, but we're going to talk about more about how these devices and how these systems that we set up digitally affect our lives. If you haven't given your phone back, you can give your phone back now. Everybody already did. It was too uncomfortable to continue. There are a lot of different takes on how we live our lives increasingly online. And if you're in this room, if you're here, chances are that when we started to express ourselves digitally, you were excited. You thought about all the ways we could represent things online, what we could build and what we can make, and you were like stoked. And when we first started, we had GeoCities, which is like a bastion of creative internet explosion. It's like honestly the greatest thing in the world. We already hit the pinnacle of the web right when we started, like we can all go home now. We also had MySpace right at the beginning. People learned how to code through customizing their profile. And in doing this presentation, and everyone was friends with Tom. And in doing this presentation, I revisited my old one, which is like a time capsule to terrible bangs and old weird art pieces. I don't know why there's a photo of me in a bathroom. I guess it was a phase or something. Some of us wanted to be elite programmers, so good at programming that our fingers were literally on fire. We've all just like watched the movie Hackers, and that's why we got into programming. But whatever your impetus for starting was, the internet allowed us to share our lives and express ourselves in some of the most creative, unique, interesting, and bizarre ways that only human minds could imagine. But the only constant is change. And the more many people were online and the more we just disseminated all of our information online, we had to find ways that we could build, tag, sort, and analyze all of the data that we were collectively making. And as things got more complicated, what we started to realize is we were summations of these digital models. We could be summarized in just one way. These inaccuracies start to be reflected in the way that we're learning. People are using search engines rather than libraries or teachers to make sense of the world that we're inhabiting. They become our societies and our institutions. And tech can be so magical in this way, right? That is really why we're all here. But like anything that we express as programmers as magic, the more that it's magical, the more we can't see into ways that it might fail. I'm Sarah Drasner, known as Sarah Edo on Twitter, and I work for Microsoft. Yeah. And today's talk is called Live and Machine Learn. In this talk, we're going to explore some of the paradigm shifts that machine learning can bring. We're going to talk at first on a very high level about what machine learning is. We're going to talk about some genetic algorithms and really like at the base what it does. Then we're going to get a little bumming for a minute and we're going to talk about some ways that machine learning can fail. But we're going to bring it up again and talk about Vue.js and Cognitive Services and some of the ways that you can apply machine learning for forces that are good. We're also even going to talk about just building applications for good on the web. So let's talk on a high level about what machine learning is, and we'll kick it off with a quote by the guy who invented it. Machine learning gives computers the ability to learn without being explicitly programmed. So we're programmers, we're all familiar with if-then statements. So what if they get complicated? And I mean really complicated. So if you're building a program to understand that this is a pug and this is a kitten, you don't necessarily want to program every single dot and every single pixel inside of a pug to understand that it's a pug and then find that for every single pug on the planet. I mean, that's not how our brains work, right? So how would we do it? Well, you want to teach it a certain pugliness. You want your model to learn the essence of a pug. So in truth, there are a few ways of doing this. Sometimes, like in the example above, you can tag a set of data and your model will use this supervised data set to understand the difference between these pugs and these kittens. This is called supervised machine learning. But other times, we don't really know what we're testing. So if we ask the computer what these pugs would look like if they were bred together with a stegosaurus, well, that's not really a thing. So we'd have to use a completely different process, and that's an unsupervised process. So let's dive into supervised for a minute because it's easiest to explain in the time that we have, and it's kind of common. And in truth, there are actually thousands of supervised algorithms, and the most common one is convolutional neural networks. But the easiest to explain is genetic, so we're going to start there. So let's build a simple toy model. In order to build a pug-kitten sorter, like you saw before, first we have to build an algorithm that builds algorithms. And it will do its best to do its best sorting. And at first, it's bad at it. Not just bad, but it's terrible. But we built another algorithm to check this process and to see which ones it got right and which ones it got wrong. The ones that are wrong get thrown away. And the ones that are right circle back to the builder. Now, this sounds hacky and imperfect, and that's because it is. If we did this once, twice, or 3 times, it would fail. But we do it thousands and thousands and millions of times. And eventually what we have is something that actually is accurate, but we don't actually really know exactly how it works. So we don't have a small amount of conditions either. We build up all the gradients that make up an eye, and then we pair that together with the presence of snouts. And in truth, that's actually how we made this Linnaean system of classification way back in the day, which is kind of like a human comprehensible system set up with some of these parameters. So the part of this that I want you to remember is this as we talk further today. That point where we check, you can see how that's a very important part of this. If we have the ability to check, we must do so and keep on checking. Another very important part is the type of data that we use. If I gave it only these pug pictures to be trained on, well, that would be true, right? These are pugs. But if I only analyze on this kind of data, you can see how it might fail when we find our one true pug. So let's explore some of the ways that we've failed with machine learning as a cautionary tale. And I'm calling this section, "The Road to Hell is Paved with Good Intentions," because none of these examples were sought out to disrupt society or anything. These are really good intentioned examples, but it's important that we look at them to kind of understand what we're building and what we're making and how it applies to the future. So let's say you need to patrol a city for crime and you don't have enough units to cover the space entirely. So it might make sense to figure out where all the crime is happening. So we just have some patrol units that focus on the areas of the most activity. But the problem is, not all crime is created equal. There are some things like nuisance data where people are panhandling or homeless, and that gets mixed in with the rape and murder kind of violent crimes. You can't only analyze the rape and murder violent crimes because there's not a lot of that data. So in order to make it statistically significant, we're training on all of that data. But the problem is, nuisance crimes tend to be clustered in poorer areas. So what ends up happening is you have patrol units circling these poorer areas, and then it feeds back to the builder, and we only have data about these poorer areas, and it feeds back, and that's an example of bias sample in machine learning. This is what the software predpol does, and this is an example of where machine learning has kind of failed. So, and the source for this is Weapons of Math Destruction, which is a really, really wonderful book that you should definitely check out. And some of the issue with this is once you're a criminal, you kind of tend to stay in the system. The US Department of Justice has found this. So 68% of people who are in jail, even if they come in like a really low crime, end up becoming reoffenders in the next 3 years, 77% in the next 5 years. And part of the reason for this is that people report finding it really hard to fit back into society once they're in jail. And another reason for this is because you have to disclose that you were unemployed, or on your employment sheets that you were in jail. So employment becomes more difficult. But here's the thing, employment is the #1 indicator for whether or not you'll be back in prison. So it becomes kind of a self-fulfilling prophecy. Another thing is the way that we even analyze to get into jail. So we have this thing in the United States called COMPAS questionnaires that we give people who are going to jail, and we use that to figure out how long their sentencing is. So this score is used to determine how long a sentence is rather than the judge picking up on this. In an evaluation of more than 10,000 of the people who were analyzed by COMPAS, found the risk scores were kind of a startling difference. Black defendants had scores fairly evenly matched across the board, 1 meaning no risk, 10 meaning they'd have a long sentence, whereas the white risk assessments look quite different. Many are assessed at 1, steadily decreasing to few at 10. But what if that's just valid data, you might ask? Except upon analysis, it's not really. The study showed that blacks were twice as likely to be labeled as a higher risk and not reoffend, while their white counterparts were labeled not as risky as they were. So what does this look like in real life? We have someone like James Ravelli, who's low risk at 3, Robert Cannon, medium risk at 6, and James Ravelli had a prior offense of 1 domestic violence, aggravated assault, 1 grand theft, 1 petty theft, 1 drug trafficking, and he subsequently reoffended. Robert Cannon had 1 petty theft, that was it, and he never subsequently reoffended. 2 DUI arrest, Gregory Lugo, low risk at 1, Mallory Williams, medium risk at 6. Gregory Lugo had 3 DUIs and 1 battery. Subsequent offenses, 1 domestic violence battery. Mallory Williams had 2 misdemeanors and no subsequent offenses. I could keep going, there's a lot of examples of this. This is just one example. And these kind of algorithms don't just affect black people. Zilli is a construction worker who was really low on cash, so he stole a piece of equipment from his work and he sold it for parts. Since he was in jail for this, he's turned himself around. He's going to church, he's volunteering, and he mentions that none of those things that he's doing end up in the COMPAS score. So his COMPAS score doesn't reflect all of the things that he's doing to better himself as a human. The book of Weapons of Mass Destruction covers some of these key tenets, and it talks about what makes COMPAS fail. It has no transparency, right? They basically built the algorithm and they shipped it out to people who use it, and they don't understand how it works, which is really important. And because of that, it doesn't adapt over time. It doesn't do that checking step that we talked about before. People also use it without asking questions. That's another thing, is that because it's magical, because they're just using it and they're not questioning it, they're not retraining it, they don't know how it works, and they're not asking if it is working properly. So, and that's including whether or not this is the right place to use one of those algorithms at all. The thing about machine learning is that it wants to predict the future, but it can only really evaluate the past. And so we have to keep that in mind when we're using it. Brennan, the creator of this, said, I don't like the idea myself of COMPAS being the sole evidence that a decision would be based on. He didn't actually build this technology with the idea that it would be used for sentencing. But if you're ever a creator of an open source technology, you'll know that things start up and they're used in ways that you didn't imagine as we put them out into the world. This is why it's critical for these kind of technologies to be transparent in order to not be abused. They can't be magical. So people will say that algorithms aren't biased, but they're written by people. This doesn't only happen to criminals, it happens to us too. Machine learning is now incorporated into a ton of tools that we use every single day. So our data is mined and resold. You probably know about this, but Axiom, a data brokerage, had an average of 1,500 data points for 500 million consumers, including the entire adult population of the United States. That was in 2012. and that's just one company. So when I used this Chrome extension called What Does Facebook Think About Me, I could analyze the ways that Facebook had tagged me in their system. And I found that there's a bunch of things in there that are really very obvious, and if you followed me on Twitter, you would know anyway. I like dogs, I'm a software developer, I like science, so it's nothing really shocking there, but it also tagged me with a few really strange things. Nothing wrong with any of these things, they just don't express my interests. I don't know why mermaid is there. I've never read a James Patterson book. I'm not into knitting. There was also like trench coats in there, I don't know. So Facebook uses these tags to drive directed and targeted ads, right? You probably know about that as well. And you can use it to target on demographics, including race. Well, a few years ago, they found that they were also allowing people to do that based on buying a house, which is actually illegal under the Fair Housing Act of 1968. But here's a really important part of this. Once pointed out, Facebook fixed it. That's a big part of all of this, because as software engineers, you might be sitting here like, I could never build a thing that never fails, right? That's just not possible. But a big part of this is course correcting when we've done something wrong. So Facebook did something that was really great here. And it's not intrinsic to Facebook that something like this arrives. And another issue that you might notice when you're seeing this is that you don't tell Facebook your race. They're targeting based on ethnic affinity by the same algorithm that thinks I'm into mermaids. So it's not necessarily super accurate. I've also personally seen this. At one point, I worked for a company that was starting to work with machine learning, and they brought up this project, and I had just read about the legality of this particular idea earlier that week, namely that it wasn't legal, and I just brought it up. And I wasn't a PM for this project. I wasn't driving the project. I was just a regular software engineer, and my job was to make things happen. And once I brought it up, they said, oh yeah, I think you're right. I don't think it is legal for us to do this. So just saying something when you think something isn't right, even if that's not your core facility, is a really important part of being an engineer in this day and age when we're working with machine learning. It's not that digitizing the world is inherently bad, but the more technology becomes embedded in all aspects of life, the more it matters whether the technology is biased, alienating, or harmful. And these tales are pretty dark, but machine learning offers a ton of amazing benefits as well. As my brilliant coworker Paige Bailey says, it's like the risk we take every time we get into cars or airplanes. They've completely transformed every aspect of life and made so many things possible that would have been impossible before. But they're inherently dangerous and can be seriously misused. So think about it. I'm in this room. I live in Denver. I'm in this room and joining you today because I took a plane here. I wouldn't necessarily not want to use a plane because they can be used for weapons. They have been used for weapons in the past. We just have to understand that that risk is there, and so treat them with that idea in mind. Treat them with some sort of reverence. Okay, so now I've seriously bummed everybody out, but let's explore some of the wonderful applications of machine learning and what we can do with it. As I mentioned, I work for Microsoft, and in Azure we have a thing called Cognitive Services. There's a specific API called the Emotion API, and what it allows us to do is to take things like pictures and videos and detect the emotions that it sees from what the computer sees. So it can be used to do things like this, which I built in Vue.js. Wow.
I got up there.
Yeah, there's stuff up there, huh? Okay. So it might not have any other use case other than entertaining my 4-year-old stepdaughter, which can also be pretty magical, to tell you the truth, but let's put this to useful use. Okay, so what if we applied it to something that we really need online? So I was mentoring a blind woman, and she mentioned to me that it was really difficult for her when she was left out of the conversation on Twitter or other types of social media and even news sites because there were no alt text with photos. So I used another cognitive services offering, which is the computer vision API to create this. So this dynamically creates the alt text that you see right above the photo. And just to show how this works, we're going to dive into some of the code for it really briefly. It's actually really easy to use. So if you haven't worked with Vue before, this is how we're calling this method on this component. You can see we have a change event that calls this file upload method. That could be named anything. Dancing Tango Monkey Pants would also suffice, as long as it matches what we're using in our methods. So I have my file upload method. We'll get the image from the user, and we're going to store it here. And then you can see here, we're doing a simple Axios call to the computer vision API, and it will return a blob of data that we can then use to analyze the image. It doesn't have a lot of overhead, and you can get really detailed analysis without doing too much. We're using Azure Cognitive Services to analyze the image in two different ways. One is to see what the image contains, and also to see if there's any text in that image. I'm only showing one of these things here for the sake of not showing you a million things on this slide, but this demo is open source. All of the demos I'm going to show you today are open source, so I'll let you look through the code and fork them and play with them all you want. Now that this is built, I'm also making a Chrome extension so that blind people can use it on any site that they go to and apply alt text where there is none. So this application of machine learning can help us bring more people into the conversation and broaden our reach. It's not perfect, but it's headed in a really good direction, where all of a sudden the people who were left out of the story can now be part of it. And here's one of the interesting things about these kind of applications, is that you're not excluding the people in the center. You're just bringing more people into the conversation, which means that you're actually meeting business goals. You're reaching a wider audience. So now you can see how Azure Cognitive Services can be used through a simple API call, but what if we wanted to dive into that abstraction just a little bit? So I used a machine learning process called LUIS to build natural language processing, and we can actually train some models with LUIS, so it's actually pretty interesting. So we can use it for apps, bots, IoT devices, and in order to dive into the code, I'm going to first give you some context around why I think this can be really cool. So many years ago, I worked at the Field Museum of Natural History as a scientific illustrator and web developer, and I made sites for them. I was a contractor at the time, and I was getting on a bus, and as I was getting on the bus, the doors closed on my arm, and the bus driver didn't see me and started to go. And he only stopped when people on the bus started yelling. And while he was doing that, I heard a pop in my wrist, and that was the sound of a tendon ripping. I tried to take some time off of work, but I couldn't take that much time off of work because I was a consultant, a contractor, and I was paid hourly. So, I needed to keep on working and work through the pain. And I could probably show you in a few different ways, like how web development was affected, but I was actually making art at the time, and that's a little bit more visual and illustratory, so I'm going to show you through that process. So, at first, I used to do these drawings that were done with ballpoint pens, and they're like cross-hatching gone mad. They're just like me dragging the pen and making a ton of little marks until it builds up a gradient. So at first, these became really painful to make. Then I had to kind of use etchings and things like that that were a little bit wider. The cross-hatchings were a little bit wider because I was in a little bit more pain. Then I switched to painting, and you could see I started doing stuff that I wasn't doing before, where I was really expressive because I just couldn't. It was too painful to do any other kind of brush strokes. And then I couldn't use my right hand at all, and I had to start using my left hand for some of these tasks. But then I was overusing my left hand because it wasn't used to it. And soon I couldn't brush my teeth, and I couldn't put on my pants, and all sorts of things. And I basically couldn't work. It was very, very painful for me, not just physically, but also because I really like working. So doctors know this, and sorry. I'm just going to keep showing that over and over again. So I was forced to do one of the hardest things that I ever had to do in my life, which was slow down. It's really, really tough when you have to take off of work because you're in pain, not because you are choosing to work. Everybody says, oh, I want to rest, but imposed painful rest is not that great. And people don't actually rest the way that they're supposed to. And doctors know this, so they have to train you to think about your body and what you're doing to your body as you're working, or as you're sitting, or as you're living in order to heal yourself. So there's a thing called biofeedback, And what they do is they hook sensors up to your brain and to your arms and to your legs, and they make you sit in a certain position and breathe in a certain way. And the whole point of this activity is to raise the temperature in your arms. When you're stressed out, all of the blood drains from your arms for in flight or fight, and it goes into your head to think and your feet to run away. And this is a big deal if you're trying to heal, because if you're not getting any blood circulation to your arms, you're not healing your arms. You're not carrying oxygen. Your blood actually you need blood circulation to heal. So in 2 minutes of this activity, I raised the temperature of my hands by 10 degrees. And that's a very, very good thing for someone who's healing. And because I'm an engineer and I was like, oh, I'm not sure about all of this. This seems very hippy-dippy or something. I decided to test the whole thing. So I thought about something that really stressed me out. And all of a sudden the machine went crashed and was like beep, beep, beep. And she's like, whatever you're thinking about, stop thinking about it. So it was through that process that I learned that that's actually a really, really important piece of listening to our bodies and understanding what's happening with our bodies. So I built this demo with my coworker, Brian Holtz. So you can't hear too well, but I'm saying that I'm feeling excited, and I'm telling it more and more to adjust the intensity. I can say, I'm saying nervous, and then another visualization comes up, and I'm saying tipsy, and then I'm able to say less, and then the visualization is updating as I'm telling it different things. And we don't have enough time to run through this entire application, but I'm giving you a bird's eye view of everything that's going on here. So we're actually talking to that Lewis API that we're training. The Vuex store is like Redux, if you've ever worked with, or NGRX, or any kind of centralized state management. If you've worked with Angular or React, it's going to hold the state for the entire application. And the components are basically going to gather data from that. So the Vuex store is the thing that's going to make the Axios call. All of those components are going to talk to the Vuex store, and I have a number of dependencies like 3JS here. And here in the store, in Vue.js, or in Vuex, I'm using that URL, and you see that's that simple Axios call that we did earlier. And we're also going to take all of that data, and we're going to hold that in our state. So we're going to let the state know that we need to keep that and basically understand those utterances. And here's the state itself. So we have a few different UI states. We have idle, which is awaiting user input, listening, which is listening to user input, and fetching, which is getting the user data from the API. And we also are starting off with none for the intent and the intensity, the intent being whatever emotion we have, and the intensity being that more or less. So here we're actually allowing ourselves to set that UI state when we're listening to things, but one of the things were when we hit the button, and that one we want the recognition continuous false because we want it to be triggered on a button click, whereas when it's true, or I'm sorry, when it's false, then we are listening continuously to people talking. So there's basically two ways that we can work with Lewis. It can always be listening to us, or we can trigger it. And here in the Lewis dashboard, here's how we're training those intents. So we actually have, they kind of suggest that you do like app.blank, app.blank for different intents. And then we also have the intensities, which are mapped separately. So I know how to distinguish between those two. So I have calm, excited, and you can see that I can really train it with anything. And within the calm, this is just one of those. If we go inside one of those, I'm training it on a bunch of different sayings, and it already knows some phrases. So as I'm training it with those things, it's becoming more intelligent in terms of what it understands in general, but it's also using other things that it's already learned to kind of map that correctly. So now we can change that. Mutations are the only way to change state in Vuex right now, so we're actually changing that counter that goes up and down, and we're going to use that counter in the 3JS visualization in Vue. So here we're creating shapes, and we've got a few different things that we're holding in the state in Vue. And we have these materials and the torus knot, which is basically the way that I'm making this is there's one torus knot shape that's like rotating all the time, and then we've got a kaleidoscope effect that's seeing into that torus shape. And as we pick different things, we're picking like wireframe versions of it, or different colors, or what have you, and then as you say more or less, it's affecting the zoom and the amount of dimensions that those shapes have. So we're also, a lot of people take a Three.js visualization in Vue and they'll instantiate it, and then in order to change it, they'll remove it entirely and then add it again. But that's not very efficient. So I'm using buffer arrays here to make this more efficient. So we instantiate it once and then we update it. So here's how we're animating it. We're using request animation frame, which is similar to recursion in the way that it works. We're basically using it to call itself. And then if you're not familiar with Vue, we have this thing called watch. So there are different properties that were registered as dependencies. So anything in state or data is registered as a dependency on that component. And when we use watch, we're going to say to shape zoom, I'm watching this shape zoom. Anytime it changes, I want to plug into that. So Vue is a reactive framework, which allows us to have some hooks with which to observe things. And this watch allows us to dive into that abstraction. So anytime this updates or changes, we're able to change things. So when that shape zoom changes, we're going to reinstantiate the way that we use those create shapes with the buffer arrays. We're going to cancel the animation, and then we're going to restart the animation. And the repo is here if you want to dive into any of the code. Eventually, what we're going to do also is make it work with the Muse headband. It was important to not make it work with the Muse headband first because not a lot of people have those. But they're a meditation headband that actually exposes an API that you can use. And there is a person who made a repo that has a JavaScript port. So we can actually make it work so that you're not even having to use Lewis for that first part. It's just going to read and analyze your thoughts, create the visualization, and then you can talk to it with Lewis and update it, and then you're not using your hands at all in order to create these visualizations that are showing your mood. And there are other implications of ML in medicine. You saw some of them in the keynote, but there are some really, really cool ones out there. Sophia Genetics is training algorithms to diagnose diseases through DNA analysis. All4Cure is a social network for cancer patients where patients can enter diagnosis data and treatment so that it can be analyzed. This one is a really cool one to me because my fiance has cancer. So he can go in and write, all of the things about his treatment, what type of cancer he has. And doctors can't read every study that comes out, and they can't analyze every single patient around the world. So when people go into the social network, what happens is the machine learning algorithm trains on all of the data from all of the cancer patients, and they find out what's being used most effectively. So they can find out what treatments are actually working for people and what treatments are not. And it can become a more intelligent way for doctors to have access to this information really quickly. Health Map algorithm spotted an Ebola outbreak 9 days before the World Health Organization, which is a huge deal because they're exponential growths for these kinds of outbreaks. So if you're catching something like an outbreak 9 days before, you're saving a ton of lives. It will grow exponentially over those 9 days. So you might be thinking about all of this, and if you're an application developer, you might be saying, okay, that's well and good, but I'm not a data scientist, and I'm not really sure how cognitive services or machine learning can fit into my applications. So what can we do with some of the technology that you already know as a web application developer? So let's talk about some uses for application for good. So there's a firehouse near my house, and they have some sufficiently complex systems to help make sure that everything is online and functioning. So I went out to their station, and I learned to learn how everything works and asked and see if there's anything I could help them with. And here's what I learned. They have this truck, and inside the truck, they have this computer that is basically using an internet connection to use an application that requests backup, requests water, all of those kind of things. And the app is really simple, purposefully so, because they want to be able to use it quickly at a glance if they're in emergency situations, big, pushy, colorful buttons, and there aren't that many things that they might need. So for their use case, what they created is perfect. But I asked a few questions, including what happens if they're suddenly offline. So what if they can't communicate? And right now, currently, it fails. They're hosts. Get it? Hosts? No. So here's our opportunity. What I did was create a really simplified version of their app, preserving the basic layout, but I made use of service workers and background sync. So I wanted to alert them when they're offline. When they're offline, queue all the messages, so get it ready for when they are online. And then when it's back up, send them out, even if a browser tab is closed. So even if somebody accidentally shuts down their computer, it will still work. So here's the application. You can see if I'm requesting water, I made some colorful logs so you can see that a little bit better. Now I go offline, and you can see that they're alerted, and then we've requested backup and the sync is registered. I'm going to close that tab, and if I go back and open the console, I can turn the Wi-Fi back on, and then the sync event fires, even though we didn't touch anything. So even if people forget about it or anything, it will still work later. So here's how we're alerting them when they're offline. We're using whether or not we're using a window.event listener and navigator.online to see whether they're online or not. And then we're going to register the service worker when a request is made. So if you haven't worked with service workers, this is a really important part. Service workers don't work like a normal JS file. They're almost like communicating with the server. Like you have a file that's completely separate and you're throwing it over the wall at that file and then getting information back. So we have to register it in a different kind of way. We have to register it and then talk to it and then get information back from it. So we're going to create the sync event. So after we've activated and installed the service worker, we'll strip out the type from the event tag and pass it into a function that will process a fetch request whenever it gets connectivity. And in that function, we'll fetch our URL, which is a placeholder server in this case, and we'll check if the response has happened. And once it has, we'll send the message back to the client with post message, and we'll send the response with the type of resource that was requested. Then we can alert the user when the request was finally sent, and we're good to go. But the most important part of this demo is not actually the demo, it's where we started. We started by asking questions. I went to the firehouse and I asked questions and I listened. And there were many times in that conversation where I didn't even know if there was something that I could do to help. But I still asked questions, and we have to ask questions. We have to ask questions at the beginning, like in the Firehouse application. We have to ask questions once it's deployed, like in the criminal scores. We have to keep evaluating where these systems are going to make purposeful decisions to help people and to course correct when they don't. I see a lot of tech that asks questions about how to make our lives more comfortable, which I appreciate. Heck, on the weekends, I build silly things like this cocktail finder, which really just, finds me cocktails. But it seems like I see a disproportionate amount of tech that focuses inwards rather than outwards, focused on helping people with money rather than finding people who might need real help. And there are a lot of opportunities out there to help. You might already have the training to make them. It just takes a little bit of imagination and exploration. So what I want you to think about going forward is this. I truly believe that you're some of the brightest minds of this generation. As we build applications for the web, we're actually also building the pillars that our society rests on. This could mean building new features. This could mean advocating for accessibility. And this could be as simple as raising your hand when you think something isn't right. It's not just your job to create these applications and do as you're told. It's also your job to ask, are we building correctly? Are we building the right things? And are we building them well for all the digital lives that we touch? Thank you.